Hello, my name is Patty Trejo. I am in your ECE211 class. I'm using a new system. I wanted to try something else from last year because last year I used a very simple, just the screencast-o-matic. This one's an actual OBS, so gonna see how it is, test it out for this one, and see what I can do better in the next ones. Okay, well, so this is the weekly summary for week 1 and week 2. I started doing notes this semester. Did only a little bit just because we only had the statics and the I think it was dynamics that we started doing, but did a little bit of notes on that, and then I started writing my weekly summaries on paper so I can, easily talk about them and then just not have to think too much. But okay, so we'll start off. So here's my notebook. So yeah, these are the notes that I took for when I was watching the video. This is just a little bit of notes. I mean, most of it is I didn't want to write down too much just because it's all review for me, so I didn't have to worry about it too much. But week 1, we started with the screencasting. That was our neat resource, but it's basically the internet introduction, what you started first week of everything. So in the screencasting, this is when I found this OBS system from last semester. I don't remember who said this one was a good system, so that's what I started using. But I know I put Screencast-O-matic on there because I was like, it's very simple to use. But same thing as Screencastify, that was the same. Something I didn't know Prezi did a screencast. I knew that I just normally used it for like slideshows, but never to like do something like this. So I thought that was good information to know. And then yeah, Yarden. I think it might have been Yarden because I think he was in our class last semester. But so that's for that. So that's why I wanted to try a new system. What I learned. Oh, so I liked that I don't know, the paper that you wrote on the hypotheses and the nature of science, because I always thought it was I didn't think about it. I think someone mentioned it, I don't know, maybe a couple years ago, that everything that we learned in our science class in elementary school is all theories, like how the center of the Earth, so we have like the core and then like the inner mantle, and then like the crust. I thought, we learned it as a fact. We didn't learn it as, oh, well, this is what we think it is. And I thought that was very interesting to know that all of these theories and everything that we were taught as a kid are just theories. They're all ideas. They weren't proven. Yeah, they were supported with data, but they were never proven. They can't be proven. The same as, our solar system, how each planet is this distance, and how much gravity they have, and how much, like, all of that, all theories. Obviously, we can, we have our astronauts or satellites up in space, free falling, and they see that, but we don't see that big picture. It's all a theory. So I think it's very crazy how all of this, I thought they were, as a kid, I thought they were facts, but as I grew up, I realized, okay, well, science is never an exact fact. It's all theories, it's all ideas, it starts with a hypothesis, turns into a theory after it was supported with evidence and data, and theories, they normally go on to being laws after they were supported, and many, many, many scientists can replicate the same thing without having one that didn't work. Because that one data that showed opposed that theory, well, okay, then that theory isn't right anymore. So it can't become a law. Even if it was a law, you can still disprove it if you can calculate, if you can do an experiment and it comes out like, disproving it or wrong. But that's what we did week 1. very, very interesting. It was a lot of thinking that I was doing just because of all of that, like thinking and making, it's like realizing that a lot of things that you know, thought they were real or facts might not be. It's just, you know, a theory. Week 2, we talked about 3D printing. So the 3D printing, my dad actually has a 3D printer at home. He's actually building another 3D printer from his 3D printer to make a bigger one. But I think it's so interesting how these little parts just move together and it's connected to a whole system. I'll print out little gadgets that I find on like Thingiverse, and they're just fun and, you know, cool to play with. But I knew about, I've been seeing it on social media and like videos on YouTube about a resin printer. So it's upside down, so it dips and it pulls out and it prints. Well, I mean, it hardens resin layer by layer, but like you have to clean it and you have to be super careful about it because it's very harsh resin. I think that one's very cool. I mean, I don't think I would own it. I think it would be really cool to see it in, you know, action. But like the ones from the movie Ocean's 8 where they, Ocean's 11? I don't know. But the one where they print out all the jewelry, that's, I mean, I wish I looked, there might be some 3D printers that can make some jewelry look like that, but that would be cool. Let's say, yeah. So Kim said about the Thingiverse, yeah, I've been using Thingiverse. I've been finding everything on there and then using CADs. I think I've used Tinkercad on my own. I think we did some in this class. But I think Dakota mentioned about these little action figures, but there's this like website that actually, it's a 3D print marketplace, so you can, I would assume you can send in your ideas and they can print them for you, because I know a lot of people don't have like 3D printers accessible to themselves. But that was very cool. Okay, next one we did engineering design process. So from everything that I saw from other people posting on there, they all looked very similar to the one I found. I was researching about it, looking at different websites, and yeah, they all look the same. I mean, they all have the same idea. So it starts with, you know, having in, what is it? You ask a question, asking questions. Wow, I can't even read my own handwriting. Ask, research, imagine. Well, plan, create, test, improve, and repeat. So, asking and research basic questions, and if you get stopped there, I always just come back and I ask a different question. I'm a big brainstormer, so I will normally think about things on my own. Obviously, when you plan, gotta plan an idea, plan a project, plan a test, an experiment, whatever it is. You create it. Normally I would create, but that's in between your plan and your create. It's like your rough draft, your there's a word for it. Prototype. Your prototype first, and then you make your final model, you test it. But that would go into the circle of repeating. Like, you do your prototype, you test it, and if that goes, you fix it, create it again, and then test it, and then improve. I didn't read that part. And then you repeat, and you keep on going, and you keep on going. I think that is very interesting. Besides that, are we still going? Yeah, we're still going. Okay. Yeah, so the ones I was seeing from other people, they all looked the same. They were very similar to each other. They were just different words, but it was the same idea. You ask a question, you research, you you research, you plan, you create, you test, you improve, and then you keep on going and you keep on doing that circle for every new idea. That was pretty much everything that I saw. And I think even if it wasn't an engineering process, like, sorry, one sec. I don't know how to pause this. I will see if I can cut it out. I'm sorry. I'm getting called and I can't. And if I don't text them back, they'll keep on calling me. Sorry. Okay. Moving on. So, and then, I mean, it's a whole process. That's what I was talking about. The whole engineering design process. Even if I think I've done that multiple times and not even for an engineering project or something like that. Like when I would, make a book report or doing homework or an essay or anything, you start with, you ask a question, you are given a question, you research, you brainstorm, you start putting down ideas. Oh, like this would be interesting. And I mean, I don't know if that was just, the teaching, the beginning of many people, because like for anyone, an engineer and entrepreneurs or anyone that has to, get an idea, have a problem, and you have to solve it with a certain, that's how you will, that's any process. And I think this one, the ones we were finding online, were all very similar, and they were all very important to anyone, and I've definitely have used them back in past and without even thinking about it. Like that's the same as like when you would do like experiments for science class or my science fairs. You start with you have a question, and then you have a hypothesis, you test it, you experiment, you have the process, all the things, like the materials, and okay, now you have your conclusion, and all of that is same thing. It's a process, and I think, putting them in order and showing it and using this very simple, couple simple word process will help you widen it out when you have difficult problems that you have to solve. So, I think that is. Oh, and I'll talk a little bit about the what am I doing? No. The vectors and the statics and scalars and vectors. I've been learning vectors in every single class so far. I've learned it in my calculus class, in my physics class, and now in this class. Surprisingly, I still don't have a very great understanding of it. Like I understand like the vectors, how it has magnitude and direction, and how different vectors will give you different. I just never, like on the math point of view, like the calculating the magnitude or the angles, I've been struggling a little bit on that. So hopefully with all this different information from different classes, I can probably understand that a little bit better. And then the Newton's laws, from the video that we watched, I really liked his examples on them, because I mean we've learned about Newton's laws for many years now in physics class and everything, and like I understand what they do and like what they are, but it's great to see him in a physical point of view and see how his example about the hammer, and how if you hit it from the top and you hit it from the bottom, I really was skeptical about, like, obviously, like, with the first law I shouldn't be skeptical, but when he had it hanging and he hit it from the top of his hammer, I would have honestly thought it was gonna go down with the whole system, but it's not, because it was two different parts. So that was very cool to see. Besides that, I think that might be all that we've done these past 2 weeks. So, sorry I went off a little bit too long, but this was my week 1 and 2 summary.